Okay, so in addition to completing this, you can go back to the recording from December 22nd if you need that kind of refresher. You can also look at the key that for all the practice problems from the handout from December 22nd, which is in today's folder, if that's all you need. But you want to sketch these using the zeros, the end behavior, and add each zero, whether it's across, a tangent, or a point of inflection. Here you want to write the equation using the zeros, the end behavior, and whether each zero is across, a tangent, or a point of inflection. And here you're going to use your calculator. Might have to adjust your window. You're going to need to see all zeros and all turning points in order to answer all these questions. Include a sketch from your calculator and label all the x-intercepts and the turns. Those are the numbers that you're going to use to answer all the questions or give all the information. Okay, so then this was the other part. So you're going to write down these definitions that I'm going to go over by watching this video and complete the long division problems at the bottom. So let's get started. So absolute maximum, that is the largest function value on the entire curve. And an absolute minimum then would be the smallest function value on the entire curve. Whereas if we compare that to the relative or local max and min, that would be a highest function value, not the highest, a highest function value within the curve. And the relative or local minimum is not the lowest, but a lowest function value within the curve. The absolute minimum may also be a relative minimum, and likewise with the maximums, but you can have like an absolute maximum that's infinity, where a relative maximum would just be related to a certain part of the curve. Decreasing interval. So this should be review, but just so you have it down, y's decrease as x's increase. And an increasing interval would be that the y's are increasing as the x's increase. So we're continuing to say x's increase because when we name our decreasing and increasing intervals, we are moving along the curve from left to right. So we're going to be increasing our x's, and we can tell if it's a decreasing interval and an increasing interval based on whether the y's increase or decrease. Let's see, multiplicity, that is indicated by the power of the factor that produces the zero. So the zeros are an important part of our polynomial sketches. Zeros, x-intercepts, root solutions. So we use the factored form to find each zero, and any powers or exponents on those factors that produce those x-intercepts would tell us what the multiplicity was. So a factor of 2 has a multiplicity 2. A factor that has an exponent of 3 has a multiplicity of 3, or an odd multiplicity, or an even multiplicity. Points of inflection, that would be an odd multiplicity. So the factor that produced that 0 has an exponent that is odd that's greater than 1. Okay, so like 3, 5, 7. And a inflection is kind of like the cubic function. So as it crosses the x-axis, it kind of levels out for a minute. It continues to constantly increase or decrease, but that increase or decrease slows down for a moment as it is passing through that x-intercept. Point of tangency, that would be even multiplicity. You don't have to say like greater than 1 or anything. It's all even factors on the all even exponents. I keep saying that. All even exponents on the factors that produce the zeros of your polynomial would be a point of tangency. That is when it touches and turns. So it does not cross the x-axis here. It is a turn. Okay, whereas a point of inflection is still a cross. It just doesn't cross straight through. If those factors have exponents of 1, that's when it just crosses straight through. So root and solutions, these are synonyms. I'll put right here, synonyms. And those are just your x-intercepts or zeros. So generally, you can kind of make a Venn diagram. So in this inner circle, we have zeros or x-intercepts. Those are usually specifically on a graph. Those, points on the x-axis are referred to as zeros or x-intercepts, whereas if you are solving an equation, you may also refer to them as roots or solutions. Generally, when you see a graph, you don't necessarily refer to the x-intercepts as solutions, although they are. So it's just more, they all mean the same thing. It's just sort of like, are you talking about the x-axis points on a graph, or are you just referring to the solutions to an equation? Intercept means it is touching the axis. Note an x-intercept and a y-intercept, those are both intercepts. Okay, so touching the axis is an intercept. Obviously a zero, though, specifically would be an x-intercept. All right, so let's do a review. Hopefully it's a review of long division. The whole new math thing, I think some students never get taught long division. But you need this algorithm in order to long divide with polynomials, so which we will need in this unit. So if we long divide, we want to, it's 43,612 divided by 4. Okay, so this number, how many times will it go into this number? So first we start with just the digit that's closest to it, and 4 goes into 4 one time. Okay, 4 goes into 4 one time. And then you multiply this number times what's out here. And then we always subtract. So 4 minus 4 is 0. Then we bring down the next digit. Okay, 4 doesn't go into 3, so we would put a 0 here, and then we would bring down the next digit. 4 goes into 36 9 times. 9 times 4 is 36. Bring down the next digit. 4 does not go into 1, so bring down the next digit. And 4 goes into 12 3 times. 3 times 4 is 12. We subtract. So there's no remainder. 4 goes into 43,612 exactly 10,903 times. So let's do that over here. So we want to know how many times does 36 go into 29,452? Okay, so 36 does not go into 29. So you don't necessarily have to put a 0 here, but it doesn't go into 2 and it doesn't go into 29. So we're going to start with 36 into 294. So I guess the debate could be had, why wouldn't you just use a calculator? But again, it's the process that we need to be reminded of, because we're going to use that same process down here. But you kind of have to figure out how many times 36 goes into 294. So you figure like 36 is is a little more than a third of 100. So there's 200. So let's say it goes in 6 times. And we're just kind of using some mental math here and taking a stab that it's going to go 8 times. And I happen to know it will. 8 times 36 is 288. And then you subtract and you get 6. And then we bring down the next digit. 36 only goes into 65 one time. 1 times 36 is 36. Subtract, and we get 29. We bring down the last digit. And so if 36 went into 294 8 times, then it probably goes into 292 also 8 times. That gave us 288 before. So that's 4. So you could stop here. This is the remainder, and that's what we're going to be using here. So if you wanted to keep going, you would put a decimal here and start adding zeros. And you could take the decimal place as far as that you wanted to. But with polynomials, it's not going to work quite that same way. So we're just going to say that this is a remainder of 4, which is 4 over what we're dividing by. So the remainder is 4 over what we're dividing by. So our answer here would end up being 818 and 1/9, because 4 over 36 reduces. Okay, so let's do that with some polynomials. So we are dividing 2x squared plus 2x minus 4 by x minus 1. Okay, so we have a binomial here, but we're still going to take this outer thing and this first thing. And we want to, there's a couple ways you can think of it. What do you multiply by x to give you 2x squared? Or if you had 2x squared divided by x, what would that give you? So x times 2x would give me 2x squared, or 2x squared divided by x would reduce to 2x. Okay, so basically how many times is x going to 2x squared? 2x times. And then just like we did with the numbers, then we take this and we multiply, but we're going to multiply by the whole binomial. So 2x times x is 2x squared, and 2x times -1 is -2x. Always subtract. That should go away. If it doesn't, then you put the wrong thing here, or you multiplied wrong. And then 2x minus -2x. That's the same as 2x plus 2x, so that's 4x. Then we bring down the next term. And again, look at these outer things. So x times what gives you 4x? Or 4x divided by x. It's plus 4. And then 4 times this whole binomial gives you 4x minus 4. If you subtract, you get 0. So there's no remainder. So when we long divide polynomials, if we don't get a remainder, then that tells us that this is factorable, and this is one of our factors. So this trinomial factors into x minus 1 times 2x plus 4. That can still be factored by taking out a GCF of 2. But x minus 1 is a factor of this trinomial, which means that x equals 1 would be a 0 of the polynomial. So this one's going to have a remainder, so let's look at how that goes. So 4x squared minus 6x plus 1 and divided by 2x plus 1. Okay, so we're looking at these outer things. 2x goes into 4x squared 2x times, right? 2x times 2x gives us 4x squared. So multiply this 2x times this whole binomial. That gives you 4x squared plus 2x. Subtract. These should cancel. If not, figure out what you did wrong. Negative 6x minus 2x is negative 8x. Bring down the next term. Go back. So 2x times what gives you negative 8x? And the answer would be negative 4. And then multiply this negative 4 times this binomial, and you get negative 8x minus 4. Then we subtract. Again, those should cancel. 1 minus negative 4 is 1 plus 4, so that's 5. We don't have anything else to bring down, so we just have a remainder of 5. And so that's going to be plus, because it's a positive 5 over 2x plus 1. So we take, just like we did up here, we took our remainder, and it was positive, that's why it's a plus, divided by this number out here. So positive 5 divided by this factor, so plus 5 over 2x plus 1. So that means 2x plus 1 is not a factor of this trinomial. Negative 1/2 wouldn't be a 0. So if you don't get a remainder, then that is a factor. You can determine that that is a 0 of the function. Whereas here we got a remainder, so 2x plus 1 is not a factor, and the related 0, negative 1/2, would not be a 0. Okay, so make sure that when you upload your assignment, you have all of this. It doesn't have to be on this paper, but you need to have all these definitions and all this long division. And then also these review problems. Again, you can look at the recording from December 22nd. And I also, in today's folder, have the answer key for all the problems from that day as well.